Mahaganathipataye Namaha. Good evening. Good evening, children. Good evening. Good evening. Good evening. Am I audible, children? Am I audible? Okay, good. Is my voice clear? Okay. Yes, good evening, Sadil. Yeah, today we are going to start problem solving in the chapter Similarity of Triangles. Morning we have discussed, in 10A I discussed some problems, 2-3 problems in 10A, and 10B I explained the concepts. What is basic proportionality theorem, what is its converse. I'll try to recall it once again. If a line is drawn intersecting two sides of the triangle at distinct points parallel to the third side, then it divides the other two sides in the same ratio. That means there is a triangle ABC and there is a line L which is intersecting two sides AB and AC at distinct points. The line L intersecting AB at D and AC at E. Moreover, it is parallel to the third side. Not only it is intersecting the two sides of the triangle, it is parallel to the third side also. Then this line divides the two sides AB and AC of the triangle in the same ratio. That means AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. This is what basic proportionality theorem, which is also known as Thales theorem. Okay, now once again, if a line is drawn intersecting two sides of the triangle at distinct points parallel to the third side, then it divides the third side in the remaining two sides in the same ratio. Now, converse of basic proportionality theorem. Converse of basic proportionality theorem. A line, if a line divides two sides of the triangle in the same ratio, if a line dividing two sides of the triangle in the same ratio, then it is parallel to the third side. Here this is required to prove, and what is given? L parallel to BC. Basic proportionality theorem, line is parallel to the third side, then it divides other two sides in the same ratio. That is BPT. And what about this one? This is converse of BPT. If a line divides two sides of the triangle in the same ratio, then it is parallel to the third side. Okay, na? Now, using this, we are going to solve problems. Okay. And even corollaries of basic proportionality theorem, also you have to keep in the mind. Okay, na? Let us start with a problem. Yeah, there is a triangle ABC. DE is parallel to BC. It is given this is 1.5 centimeters, this is 3 centimeters, and this is 1 centimeter. We need to find out this one. It's a direct question. Okay, na? In triangle ABC, DE is the line parallel to BC. Okay. It is given AD is 1.5, DB is 3, A is 1 centimeter. We need to find out AE. So by basic proportionality theorem, what we can write? AD by DB is equal to AE by EC. That is 1.5 by 3 is equal to 1 by X. 1.5 by 3 is equal to 1 by X. Now this is nothing but 1 by 2 is equal to 1 by X. X is 2. So EC value is 2. Okay, na? Now, next question. Next question. Let this triangle be PQR. Okay. And let it be, the line is EF. Line is EF. PE is given 3.9 centimeters. EQ 3 centimeters. PF 3.6. And this is 2.4. Okay. Now, we need to verify whether EF is parallel to QR or not. We need to verify whether EF is parallel to QR or not. What is your answer, children? Can we say that EF is parallel to QR? Waiting for your answer. What we have to test here? What we have to verify? We need to verify PE by EQ value. Then PF by FR value. If they are equal, then EF parallel to QR. If they are not equal, no. So everyone is saying no answer. That means the ratios are not equal. Is that right? Ratios are not equal. Okay. Very good. I think we'll get 3 by 3.9 by 3 is 1.3. 3.6 by 2.4 is 3 by 2, which is 1.5. So both the ratios are not equal. Both the ratios are not equal. So that's why EF is not parallel to QR. Okay, na? Now, so In the second Roman, you observe there are two more problems that you need to see whether EF is parallel to QR or not. You have to observe in the remaining two problems in the second Roman in 6.2 exercise. Okay, na? Now third problem. Third problem. ABCD is a quadrilateral. Line these two are parallel lines, and these two are parallel lines. It is given. Okay, na? What is given? LM parallel to BC and LN parallel to CD. What is required to prove? AM by AB is equal to AN by AD. AM by AB is equal to AN by AD. First observe the ratios, children. AM by AD, AB, AM by AB means part by whole, part by whole. AN by AD, here also part by whole. Okay, na? We need to prove that. So in order to apply basic proportionality theorem, we need to consider triangle ABC and ADC separately. In order to apply basic proportionality theorem, we need to consider triangle ABC separately and ADC separately. Okay, na? Proof. Consider triangle ABC where LM parallel to BC. Consider triangle ABC where LM parallel to BC. Okay. Then by basic proportionality theorem, basic proportion AM by AB part by whole is equal to AM by AB equal to, children, what I can write? AM by AB, what I can write? Yes, AL by AC, very good. AL by AC in triangle ABC. In triangle ABC. No. So any no. Consider triangle ABC only ABC triangle. In ABC triangle, we have a line LM which is parallel to BC, intersecting AB at M, AC at L. Okay. Then by basic proportionality theorem, AM by AB equal to AL by AC. Okay, na? Now, consider triangle ADC now. Consider triangle ADC, LN parallel to DC. LN parallel to DC. Now, by basic proportionality theorem, AL by AC, AL by AC, part by whole, AN by AD, AN by AD. Okay, na? Now, we got two equations over here. We got two equations. From 1 and 2, what we can write? Things which are equal to the same thing are equal to one another. Things which are equal to the same thing are equal to one another. So from 1 and 2, AM by AB is equal to AN by AD. The problem is done. What is the doubt in it, Vanshika? Actually express your doubt over there. Express your doubt over there. To apply basic proportionality theorem, we must have a triangle. In that, we must have a line parallel to one of the sides intersecting the other two sides. So that's why we are taking two triangles differently and applying the Pythagoras theorem, applying the basic proportionality theorem. First I consider ABC triangle, second I consider ADC triangle. Okay na? First triangle ABC and second triangle ADC. In both the triangles I applied basic proportionality theorem and I got two equations over here. AM by AB equal to AL by AC and AL by AC equal to AN by AD. Okay? Now next problem. Next problem. There is a triangle ABC. Okay. And AE is drawn. DE parallel to AC DF parallel to AE. Okay. What is given? In triangle ABC, DE is parallel to AC and DF is parallel to AE. And what we have to prove? BF by FE is equal to BE by EC. Okay. Okay na? Triangle ABC. From the vertex of triangle 1, the vertex A of triangle ABC, a line is drawn intersecting side BC at E. And DE parallel to AC, that is drawn, and DF parallel to AE is also drawn. That is what given. And required to prove is BF by FE is equal to BE by EC. Now, we have only one option, that is basic proportionality theorem to apply it. For that one, we need to consider a triangle. We need to consider a triangle in which a line is drawn parallel to one of its sides, intersecting the other two sides. Is that right? So, which triangle we have to consider here first? Which triangle we need to consider first? Triangle BAE. Okay, good. Triangle BAE. In that BAE triangle, in that DF is parallel to AE. in that DF is parallel to AE. Okay. Now by basic proportionality theorem, BD by DA is equal to BF by FE. Is that right? By basic proportionality theorem, BD by DA is equal to BF by FE. Now what is the second triangle that should be considered? Second triangle that should be considered. What is the second triangle that we have? BAC, very good. BAC. In triangle BAC, DE is parallel to AC. Is that right? In triangle BAC, DE is parallel to AC. Now, by basic proportionality theorem, again, BD by DA is equal to BE by EC. Let it be 2. BD by DA is equal to BE by EC. Let it be 2. Now from 1 and 2, what is our conclusion? From 1 and 2, what is our conclusion, children? From equation 1 and equation 2, what is our conclusion? Yes, BF by FE is equal to BE by EC. From 1 and 2, BF by FE is equal to BE by EC. The problem done. Okay? Take the screenshot. You can take the screenshot now. Next. Yeah. There is a triangle PQR. There is a point O in the interior of triangle. E is a point on PQ. F is a point on PR. There is another point D such that DE parallel to OQ and DF parallel to OR. And we need to prove EF parallel to QR. What is given? DE parallel to OQ, DF parallel to OR. Required to prove What is required to prove? EF parallel to QR. EF parallel to QR. How to start with this problem? How to start with this problem? Anyone? Proof. Proof. Consider triangle PQO. Consider triangle PQO. Children, see the triangles. Consider triangle PQO or POQ, whatever it may be. In that, ED parallel to QO. Is that right? ED parallel to QO. ED parallel to QO. Now, can we apply basic proportionality theorem there? By BPT, PE by EQ is equal to PD by DO. PE by EQ is equal to PD by DO. Okay, na? Now, consider triangle PRO. PRO. In that, DF parallel to OR. Now consider triangle PRO. PRO or POR, whatever it may be. POR, PRO. Okay. Now by basic proportionality theorem, PD by DO is equal to PF by FR. PD by DO is equal to PF by FR. Okay, na? Now please tell me, from 1 and 2 what we can write? From 1 and 2 what we can write? From 1 and 2, from 1 and 2, PE by EQ is equal to PF by FR. Is that right? PE by EQ is equal to PF by FR. Yeah, children. Is the problem done or anything left? Is the problem done? What is the conclusion? Yes, very good. By applying converse of basic proportionality theorem, by converse of BPT, EF is parallel to QR. EF is parallel to QR. We will get the final, sir. No, sir. What is that final? By converse of basic proportionality theorem, EF is parallel to QR. Okay na? Next question. Next question. Yeah. There is a triangle. P, Q, R, A, B, C. A, B, C. Okay. These two are parallel to each other. These two are parallel to each other. And what we have to prove? What we have BC parallel to QR. That is required to prove. Okay. What is given? What is given? AB parallel to PQ, AC parallel to PR. And what is required to prove? BC parallel to QR. Now proof. Okay. Now, how to prove BC parallel to QR? What we have to do? From where we have to start? From where we have to start? Any idea, children? Consider triangle POQ. Consider triangle POQ where AB parallel to PQ. AB parallel to PQ. Consider triangle POQ in which AB parallel to PQ. So by basic proportionality theorem, OA by AP is equal to OB by BQ. OA by AP is equal to OB by PQ. Okay, na? Now, consider triangle POR now. Consider triangle POR. POR. I think you can see that figure. POR. In that AC parallel to PR. Is that right? This is given. AC parallel to PR is given. Now again by basic proportionality theorem. By basic proportionality theorem again. OA by AP is equal to OC by CR. Let it be 2. OA by AP is equal to OC by CR. Now, from 1 and 2, from 1 and 2, what we can write? From 1 and 2, what we can write? OB by BQ, OB by BQ is equal to OC by CR. OB by BQ is equal to OC by CR. Now, what is our conclusion? By converse of BPT, BC parallel to QR. By converse of BPT, BC is parallel to QR. BC is parallel to QR. Now, 6 problems done, 4 problems left. So, we can do these 4 problems in the class tomorrow, and I can start next concept also, so that we can solve problems of 6.3 tomorrow's evening. Okay. So, that's all for today. If you want, you can take the screenshot and you can leave the class now. Thank you very much. Bye.